Good morning students. In this session we are going to see a topic on Brayton cycle from the subject ME 8792 Power Plant Engineering from the unit 2 Diesel and Gas Turbine and Combined Cycle Power Plants. Brayton cycle. Brayton cycle is an ideal cycle for gas turbine engines. Today it is used for gas turbines in which both the compression and expansion process are implemented. There are very different types of Brayton cycle, the open gas turbine cycle and closed gas turbine cycle respectively. The difference between these two cycles is during the open gas turbine cycle, a combustion process takes place and exhaust gas is thrown out. In other words, the exhaust gas cannot be recirculated. While in the the combustion process is replaced and heat addition and the exhaust gas are also utilized so as to increase the temperature of air which enters the compressor. It consists of 4 processes. The ideal Brayton cycle is actually a closed gas turbine cycle, and the step of the Brayton cycle are like following. From process 1 to 2, isentropic compression in the process. The air is compressed in the compressor isentropically from P1 to P2 during this process. And the second process is constant pressure heat addition, and third to 3 to 4 is a isentropic expansion, and 4 to 1 is a constant pressure process. In this, the process 1 to 2, the air is compressed in the compressor isentropically from P1 to P2. During this process, the pressure increases from P1 to P2 and the temperature increases from T1 to T2, but the volume reduces from V1 to V3. We can see this diagram. The compressor work is equal to mass into Cp value into T2 minus T1 in this process. And the process 2 to 3, the compressed air is passed through a combustion chamber where fuel is injected and burned at a constant pressure P2, and the temperature increases from T2 to T3. Heat added Qs is equal to M into Cp into T3 minus T2. The process 3 to 4 is the heat temperature air is expand isentropically in the turbine to the ambient pressure. The temperature falls from T3 to T4. The process 4 to 1, the air is then returned to its original position after passing through cooler where it cools at constant pressure process. These are the process in Brayton cycle. The gas turbine usually operate on open cycle. Air at ambient conditions is drawn into compressor where the temperature and pressure are raised. The higher temperature gases then enter into a turbine where they expand to atmospheric pressure while producing a power output. Some of the output power is used to drive compressor. The exhaust gases leaving the turbine are thrown out, causing the cycle to classified as open cycle. The open cycle consists of the turbine, compressor and combustion chamber. The efficiency of Brayton cycle is equal to heat added minus heat rejected by heat added. For isentropic process, we have T2 by T1 is equal to P2 by P1, the power gamma minus 1 by gamma, and T3 by T4 is equal to P3 by P4, the power gamma minus 1 by gamma. Then T2 by T1 is equal to T3 by T4. And we can write a eta Brayton is equal to 1 minus T4 by T3 is equal to 1 minus T1 by T2. T4 by T3 is equal to T1 by T2 is equal to V2 by V1 is equal to 1 by compression ratio power gamma minus 1. And then Brayton efficiency is equal to 1 minus 1 by gamma minus Rp by power gamma minus 1 by gamma. Thank you.